All right, hello. This is going through question 4 from exercise 12B. So here are some important formulas that you need to know. So the latest start time is equal to the latest finish time minus the duration. The float time is equal to the latest start time minus the earliest start time. So that's just how much difference there is between your possible starting times. And remember that critical activities have zero float. That means that they can't be delayed at all, or the whole project would be delayed. All right, for this question, we're going to complete the forward and backward scanning for this activity network. We're going to find the minimum completion time, and we're going to find the critical path for the project. Then, for each non-critical activity, we're going to calculate the latest start time and the float time. So this is just another copy down the bottom where we can fill in our examples. So earliest start time starts at 0. Okay, and then we do the forward scanning process to fill in all of the yellow boxes. So if A can start at 0, and it takes 3, that means that B can be ready to start at 3, and it means that E can be ready to start after B is finished, which is going to be in 11 days. Yeah. However, E can't start until D is also finished, and that takes 12 days. So in fact, the earliest that E can start is 12. Moving on from that, if E takes 10 days, then F should be ready to start at 22 days. Now it's also waiting for C, but C only takes 7 days. So you've got quite a lot of float time in here for C. And F will be able to start at the earliest after 22 days. F takes 20, so the finish will be able to start at 42. All right, so that was our forward scanning. Backward scanning, the last box is going to be the same. And to complete our backward scanning, we are subtracting the durations from our latest finishing times. So the latest that this can finish is 42, so we subtract 20 and we get 22. We then subtract 10 and we end up with 12. So at the latest, it can finish at 12 here. Okay, moving back again, we've got if B takes 8 and it has to be finished by 12, that means that A has to be finished by 4 for that to happen. And coming back here, again, we have 2 paths coming into the start here. So the start has to be finished again by 0 so that this D can be finished by 12 here. All right, so that was our backward scanning for the network and forward scanning. What is the minimum completion time for the project? That's our 42 here, 42. And what are our units? It doesn't tell us, I don't think. So we'll just have to say units. We don't know if it's days or hours or what. Write down the critical path for the project. So the critical path consists of the activities that, if they are delayed, that they will they'll be delaying the entire project. So they are the activities, remember, that have 0 float time, so where the latest start time is equal to the earliest start time. We can tell just by looking, and when we did this, we knew that D was taking 12, but A and B was taking 11 in total. So D is the critical project that in this section here, whereas either A or B could be a little bit delayed. C, remember, we also said had a lot of float time. It only takes 7. It just has to be finished by 22. So there's a lot of float time in there, which means that E is our next critical activity. And obviously the one going to the finish is also going to be critical. So that means our critical path is D, E, F. All right, for each non-critical activity, calculate the latest start time and the float time. So let's talk about that. We could also have talked about latest start times when we were identifying the critical path. So to figure out the latest start time, we use our formula up here. It's the latest finishing time minus the duration. So for activity F, its latest finishing time, actually that was a critical one. Let's just look at C. So latest start time is the latest finishing time for it, which was 22, minus its duration. So LST equals 22 minus 7. So it can start at the latest at day 15 if it's in days, and it will still be finished in time. So that's its latest starting time. Therefore, its float, we'll do that bit as well, which is the latest start time minus the earliest start time. So that's 15 minus 0, so it's 15. For B, we've got latest finishing time, which for this one is 12. So it's finishing at the latest at 12, minus its duration, which is 8. So its latest start time is 4. And you'll notice here that this latest start time, which is 4, is different to its earliest start time here, which is 3. Okay, so it is having a float time. So float, and all of the activities that aren't on our critical path will have a float time. So we said that it was LST, so that's 4, minus EST, which is 3. So it has a flight time of 1. It can be delayed by up to 1 day, and that will be fine. That was for B. For A, latest start time is the latest finishing time, which is 4, minus its duration, which is 3, so that's 1. And so our float is 1 minus 0, because its earliest start time is here. So it has a float of 1. And that was all of our non-critical activities. We'll just do one, that's the question finished. But just to prove the point about critical activities having 0 float time, if we look at, say, E here, we can see that its latest start time is its latest finishing time, which is 22, minus its duration, which is 10, which makes 12. And this 12 is the same as its earliest start time. So it has no float time. It can, yeah. Alrighty. That's the end.